this is worksheet number 4 for balancing double replacement reactions. And you want to look at the names of the reactants and keep in mind that they're going to switch partners, the innies and outies thing. Be sure to put the cations at the beginning of the new products. Okay, positive first, then negative. We're going to assume everything starts out soluble, aqueous. We're going to make sure that we get our charges are all down to 0 when we make our compounds. That's really kind of a tricky part. You can use that solubility table in your textbook, or you can use the one that I just showed you to try and determine if the products are soluble. If they're not, that's when we actually have a reaction, and we're going to put PPT for precipitate after it. If both are soluble, then technically there's no reaction going on, so we're going to put an X over the arrow. And then the last thing to complete this is to write the names of your new products. So let's try a couple together, and then you'll be on your own. Silver nitrate. You know silver is a +1. Hopefully you remember nitrate is a -1, so there's silver nitrate. Potassium phosphate. Potassium is a +1. But phosphate is a -3. So this would be a good time to find your purple ion sheet to help you make your compounds correctly. So I know I'm going to need I'm going to write this in pink just to remind you, you're going to need 3 potassiums to cancel the 1 phosphate. Next thing you're going to do is innies and outies. So again, start with the positive inside and go with the negative outside. And potassium's a +1, nitrate's a -1. That is the correct formula for potassium nitrate. Next thing we're going to do is the outies part, positive silver with negative phosphate. And again, since silver is a +1 charge and phosphate's a -3, I'm going to need 3 silvers with 1 phosphate ion. Next thing we're going to do is see if they're going to form any precipitates. So we're going to use our table. Remember, any alkali metal with any negative ion is going to be soluble. Any nitrate is going to be soluble. So I know that this is going to be aqueous. There's nothing going to happen with the potassium nitrate. So the next question is, what about silver and phosphate? So here's phosphate down here. Alkali ions are ammonium. They're all soluble. However, anything else with phosphate is not soluble. So bingo, we've got our precipitate. And so the products, this reaction actually will happen, and the products are going to be potassium nitrate and silver phosphate. All right, let's try another one. Copper 2 bromide and aluminum chloride. So again, copper 2 means this has a +2. Bromine's always a -1. Aluminum's always a +3. Chloride's always a -1. So copper 2 is going to be CuBr2 because I need 2 bromides to get to 0. Aluminum is big A, little l, and chlorine's big C, little l. And I'm going to need 3 chloride ions. So my possible combination, innies and outies, will be aluminum with bromine. Al is a +3, bromine's a -3. So I need -1. I need 3 bromides. And then the outie part, copper 2 with chlorine. And we know that's a legitimate compound because we've used it before. So copper 2 chloride has a sub-2. And the question is, are those legitimate possible compounds? So let's take a peek. Aluminum with bromine So here's bromide, silver, lead 2. This is actually mercury 1, it's a weird one, and copper 1 are not soluble, but everything else is soluble. So this is gonna be aqueous, aluminum with bromine, and then copper with chlorine. So here's the chloride ion, silver, lead 2, mercury 1, or copper 1, but it doesn't say copper 2. So this is also gonna be soluble in water, and we've seen it, it's the blue liquid that I use in one of the reactions that you're gonna see actually on Friday. Maybe you haven't seen it yet. So both of these compounds are soluble, they're gonna stay in solution, so this is not really a reaction that's gonna occur. No need to write the names, but I just want you to keep in mind that there's different forms of copper. Sometimes it's soluble, sometimes it's not. Since this was copper 2, it's soluble. All right, you have a few others to try on your own. Actually, I want to do one more with you. How's that? So you're gonna have to look up the formulas for the acids if you don't remember them. Let's just do this number 6 together. Copper 2 hydroxide. I want to remind you, copper 2 means it has a +2. You know, hydroxide's a -1. I need 2 hydroxides. Remember, put those parentheses around it. And then acetic acid is an acid, so it has hydrogen at the front. And then C2H3O2. So the hydrogen's a +1. The acetate ion is a -1. So remember, this is the cation, this is the anion. So we're going to do innies and outies. Hydrogen with hydroxide, well, hopefully you guys know that that makes water. I'm going to do it like this just to make it more clear. The hydrogen's the cation, the hydroxide's the anion. And then copper 2 with acetate. That's our outies part. So Cu, and then C2H3O2, parentheses, 2. We would need 2 of these to make it neutral charge. Next thing we're going to do is take a peek at our solubilities and looking, obviously, I mean, water's water. It's a liquid at room temperature. So what's going on with copper and acetate? Is there anything that can inform me on here? Oh, here's acetate. Acetate with any positive ion except silver or mercury 2 is going to be soluble. So this is also going to stay aqueous. Okay, so that means that this is another reaction that doesn't take place because all the products are the same as all the reactants. There's no, even though this is a legitimate compound, we can form it, this is not how you're going to get it. Okay. All right, good luck on the rest of them.